Okay, here's the review for the first test. You're encouraged to work problems, watch the video, stop the video, work problems, watch the video, stop the video, etc. Okay, so if you do reasonably well on the practice test, you should do reasonably well on the test itself, but again, nothing's guaranteed. In other words, it can still be on the test even though it's not on the review. Anyway, our first problem here is to create a frequency distribution consisting of 5 classes using the following data. The data is sorted just for convenience here. It doesn't really have to be, but it does help. Anyway, if we want a frequency distribution consisting of 5 classes, the first thing we need to do is calculate the class width. So I take the difference between the largest data value, subtract off the smallest data value, and since it's sorted, I know that's 81 and 15. The difference between 81 and 15, I am going to divide by the number of classes I need or want, 5. When I do that calculation, I get 13.2. Now, since we want the class width, we don't round in a typical fashion. We always round to the highest or the uppermost whole number, which in this case would be 14. So our class width is 14. So we're now ready to start building the different classes. We're going to choose our first lower class limit to be 15. Now I'm going to keep adding 14 to 15 to get the other respective lower class limits. So 15 and 14 is 29. 29 and 14 is 43. 43 and 14 is 57. And 57 and 14 is 71. To get the upper class limits, they're going to just simply be one less than the corresponding lower class limit for the next category. So 28, or you just add 14. 42, 56, 70. Now for the last one, we definitely have to add 14 since we don't know what there is no next lower class limit, and that would be 84. So here are the respective classes that are associated with this frequency distribution. The next thing I do is I go through and I determine how many data values fall in a particular class. So from 15 to 28, that's going to be cut off right here. Then the next cutoff point is 42. The next cutoff point is 56. The next cutoff point is 70. And then 84. So the first limit, the first class is going to have 1, 2, 3, 4, 5, 6 data values. The second one, 1, 2, 3, 4 data values. The third class, 1, 2, 3. The next one, 1. And the final one, 3. And so there's my frequency distribution. Okay? Now I'll just note if I wanted the class boundaries, I'll just remind you of this, it's not being asked here, but I want the boundaries. Then what I do is I take a half from the lower limit and I add a half to the upper limit. So for the first one, the class boundary would happen to be 14.5 to 28.5. The next one would be 28.5 up to 42.5, and continuing would provide the class boundaries, because if you're building a histogram, there are those that believe there should be no gap between the different bars in the histogram. Anyway, moving on to number 2. Again, stop the video and work the problem. We want the mean, the median, the mode for the following sample data. I'm going to calculate the mean, median, and mode first. The data does have to be sorted for the median, so let me do that. Lowest, most negative value, minus 5, minus 2, 2, 3, 7, 7, 8, and 12. So minus 5 is done. Minus 2, 2, then a 3, and a 7, another 7, an 8, and a 12. So I sorted it. The median is the number in the middle. So again, choosing the number in the middle, 1, 2, 3, 4, 5, 6, 7, 8, there are 8 data values. So there is no number in the middle. And so in that situation, I take the 2 middle numbers and I average them. So the median is 5. The mode is the number that occurs the most. So the mode is 7. It occurs twice. The mean, it's a sample data, so we use X bar. I'm going to just simply add up the data values. Just be careful working with negative signs. Okay. And I can't see them. I drew some lines through them. But anyway, you add up your data values, and it really kind of is that. Don't matter, but I'm more formal than probably most of y'all are. But I have 1, 2, 3, 4, 5, 6, 7, 8 data values. And so I'm going to add that up, and I'm going to divide by 8. And I did this properly. Adding up the numerator, divided by 8, the mean should come out to be 4. And again, I work with X bar because it is indicating it is sample data. For number 3, I'm going to save this right quick because I want to make sure you have the answers available to you. And if anything crashes, at least I can pick up at a certain point. Alright. Determine the mean for the following frequency distribution. It is some situations where you're not actually given the actual data, but you're given a frequency distribution. So what you do is you calculate the midpoint, which is given to you here, and you use that to represent the data that is in that particular class. In other words, if you calculate the midpoint, 5 plus 14 is 19 divided by 2 is 9.5. 15 plus 24 divided by 2 is 19.5. 25 plus 36 divided by 2 is 29.5. So again, when you're not given the data, oftentimes you represent the data in a particular class limit by really sort of like the midpoint, or if you want to think of it as another way of calculating an average. So you just take the midpoint, you add the two endpoints together and divide by 2. We are told that the number of pieces of data in this particular interval is 10. So if you think about it, 9.5 will show up 10 times in the calculation of the mean. Okay? There is no data in this particular interval because the frequency is 0. The number of pieces of data that fell in this particular interval was 20. So here's how you'd calculate the mean. You take 9.5, multiply it by 10 because that's on the average number of times data shows up from that interval. Then you take 19.5, but again, it doesn't show up at all. Then 29.5 as an average shows up 20 times. Divide by how many pieces of data you have. Well, you add up your frequencies, and that is 30. If you go through your calculation here, you should get something in a range of 22.83. Whatever you do, don't round any intermediate data values. I'm going to rewrite this for you. 22.83. And that is the mean. Okay? Never round intermediate data calculations. If you round your final answer, always keep at least 2 places more than what your data is, but that's really not indicated in this problem, so I always say usually 4 places is good enough. Alright, and then if it was multiple choice, you'd probably be able to tell which is the correct answer. Alright, moving on to number 4. We want to find the standard deviation for a given sample of data. There are 2 different formulas for standard deviation. One is for a population, one is for a sample. We want that for a sample. I'm not going to illustrate the formula here. I'm going to kind of show you how you would do this by hand. If you want to use your calculator and you know how to do it by way of calculator, you go for it. But here's what I need to do. If I want the sample standard deviation, I am going to list my data values. 2, 3, 7, 8. If you looked at the formula, you need the difference between x and the sample mean, and you're going to be squaring that. Okay? Well, I need the sample mean to do this calculation. So, go to the side, calculate the sample mean, and show yourself that sample mean is equal to 5. Okay? Add up that data. That is 7, 15, 20. 20 divided by 4 is 5. So that's the sample mean. So the difference between 2 and 5 is 3. And that's being squared. I really don't care about the minus sign because I am going to be squaring the data. You know, the difference, I'm going to be squaring it, so the minus sign is going away no matter what. 3 minus 5 is 2, negative 2 squared. 7 minus 5 is 2 squared. 8 minus 5 is 3 squared. So when you finally square it, you get 9, 4, 4, and 9. Now remember from the formula, you add up this column. This column adds up to, well, I'll put a box here, adds up to 26, right? 18 and 8 is 26, right? Okay. Now, the next thing I know is I'm working with sample data, and sample data, the standard deviation for sample data is represented by S. I'm going to take the square root of the sum of the differences between the data and the mean squared, which is 26. But then you divide that by 1 less than the number of pieces of data you have. So I have 4 pieces of data. I'm going to subtract 1 from that. If you take and plug this into your calculator, 26 divided by 3, and take the square root of that, which is an exponent of 1/2, you should get the square root of something like 8.6667. Keep at least 4 places. And then when you actually take the square root of that, you come out with 2.944. Again, if you round it 2 places, it would be 2.94. And there is your answer for this particular problem. I'm going to stop the video now, and there's going to be a second video. Because in case anything crashes, I don't have to start this all over again. Smart move.